Alright guys, now that we have seen all the different forms of quadratic equations, we are going to finish up learning targets 1 and 2. So let's take a look at the three different forms. We have general form, which we have also talked about as expanded form. We have vertex form, which we haven't talked explicitly about, but we'll do so in this video, and then factored form, okay, where we have written as a product of two expressions. So here's some examples of each type, and we'll go through what each type really tells us and what the benefits of looking at the different forms of these equations is. So in general form we have ax squared plus bx plus c. The things that we get here are a and c are the big ones. So a tells us the scale factor of the parabola, if it shrinks or it stretches. So if you look at this example here, if we think about our parent function, y equals x squared, and we say this is 1, then this should also be 1, because 1 squared is 1, okay? And then 2 squared would be 4, because 2 squared is 4. So if we think about a scale factor of 2, that's a parabola that is going to be skinnier, that is stretched up, where 1 squared will end up, or 1 will end up having a y value of 2, and 2 will end up having a y value of 8, because our scale factor is 2, so everything doubles. Okay, so that's what the a value tells us in the general form or expanded form. The c value then is our y-intercept. So the c value is the y-intercept of the parabola. So actually, in this red parabola that I just drew here, it would look something like this, where the y-intercept, the parabola actually crosses the y-axis up here at 10. Okay, so those are the two pieces of information that we get from the general form. The a value is really important, it's the scale factor, and the c value is important, it's the y-intercept, so you can get that down in your notes. Vertex form, if you can kind of tell by the name, it's going to give us the vertex of the parabola. Okay. Again, though, we still have a as our scale factor. So again, we have a as our scale factor here. If there is no number in front of a, that's just 1. So our scale factor is 1, and it has the same look, or it has the same width of a parabola as the parent function. And then the differences inside here, so if we add or subtract to x and then add and subtract to the y on the outside, that hk is the vertex. So hk, let me make that a different color here. hk is going to be the vertex of our parabola. It's important to note here that the equation for vertex form is x minus h plus k. So here, the minus 4 plus 10, that means our vertex would be 4, 10. Okay? Now when we have plus 1 and minus 4, it would take subtracting a negative to be a plus 1, so that our vertex is going to be negative 1, negative 4, because we always subtract x in there, or h in there. And you can remember when we talked about the fact that when we translate a graph, if we move to the right, that's actually a subtraction in the x value. If we move to the left, that's actually an addition. So it would make sense that this parabola moved to the left and its vertex is negative x, and then it moved down, so it's negative y. This one is moving to the right 4 and up 10. This one is moving to the left 1 and down 4. And we've talked about that in our translating of quadratics in the beginning of this unit. And then finally we have factored form. It's written as a product of expressions. There's really no formula for factored form. We have a product of factors. Okay, so either something that you have to FOIL or just use the simple distributive property. From here, it's easy to figure out the roots. We would know that a root here would either make this 0 or this 0, so our roots would be 6 or negative 3. Here our roots would be 0 or 5. And then from there we can figure out the vertex by taking root 1 plus root 2, dividing it by 2, and that is the vertex the x of the vertex, excuse me, and then you plug that x in to get the y of the vertex. Okay, so those are the three different forms and kind of why each is beneficial. And learning target 3 is actually going to ask that you solve using one of the three forms that we've learned, either the quadratic formula, using square roots, or factoring. And based on how the problem is set up in one of these three forms, it's easier, it's better to solve one using one method over the other. Right? So for this example, we're asked to write an equation of the parabola in factored form, vertex form, and general form. Okay? When we have a picture here, I would say it's easiest to either go with factored form because we know our roots, or vertex form. With both cases, we're going to have to think about our scale factor and be testing that as well. So I'm going to go ahead and write this in vertex form. I know the equation for vertex form is y equals a times x minus h squared plus k. Okay, so if I go ahead and I plug in my vertex, I have y equals a times x minus a negative 1 squared minus or plus a negative 8. Okay, so I can also write that as y equals a times x plus 1 squared minus 8. Okay, and notice that I'm missing my a, so I need to figure out what my scale factor is. So if I compare this parabola to the parent function, if I compare that to this, I can see that I have shrunk this parabola. I have pushed down on this and made the parabola fatter, which means my scale factor is going to be less than 1. We've talked about that before. So let's actually look at the differences here. As I move over 1 in my parent function, I go up 1. 1 goes up 1. If I move over 1 in my new function here, I go up a half. Okay? If I move over 2 in my parent function, I go up 4. If I move over 2 here, I go up 2. So I'm seeing that it looks like I'm factoring, I have a scale factor of a half. Let's check one more time. If I go over 3, I go up 9. If I go over 3 here, looks like I go up 4.5. All right, so that means I have a scale factor of 1/2. So my final equation here should be y equals 1/2 of x plus 1 squared minus 8. So I'm going to first go to general form, so I'm just going to simplify this expression. This would be written out as 1/2 x plus 1 times x plus 1 minus 8. And then, so if I'm just doing some math here, I'm going to FOIL these two first and then distribute in that 1/2. So I'm going to have 1/2 of, all right, so now if I distribute in that 1/2, and these would be 2 x's there, then I have 1/2. So my final form here would be y equals 1/2 x squared plus 1 minus 7.5, because we have a negative 8 and a positive half. All right, so finally, if we get to factored form, I'm going to just use our roots here and then the a that we got in both vertex form and expanded form. In factored form, that a can go out in front as well, so that's just going to be the leading coefficient. And then I'm going to just have 2 sets of parentheses here with x's and then my root. So it turns out that if I have negative 5 as a x value, then my y value will end up being 0, which means negative 5 plus 5 would be 0. So negative 5 plus 5 would make this 0, and then everything would be 0, and y would equal 0 there, therefore giving me one of my roots. And 3 is also one of my roots, so a negative 3 would be in this set of parentheses to undo that. All right? So that's kind of an easier way than looking at the boxes here from general form and trying to figure out what 7.5 or what would multiply to 7.5, add to 1, and have a leading coefficient of 1/2 there. And those are our 3 forms. We're not going to actually ask you to write all three forms, but we are going to ask that you are able to justify the conversion between the three. So know what the benefits are of each type and how you would get them from a graph. Okay, so for class, why don't you try to rewrite y equals 2 times the quantity x plus 3 squared minus 5 in general form. So just as I did, going from here to here, you're starting off in vertex form, try to expand that into expanded or general form.